Yeah, hello, my name is Samuel, representing Team 12. Um, Basically, I'm going to do a quick walkthrough about Capstone project. And basically, this is to simulate a car charging station that which several cars can be added to different queues in the charging station, and they get charged for a specific period of time. And after the charging of each car, they leave the queue, and other cars are charged until the charging is done. Then the queue is empty. And so what we did basically is to create a charging station as an entity. And so we can start multiple instances of the charging station. And we can add also, we can create a simulation of different cars. We create a car as an entity as well, which we can add different instances of the car to a particular charge, to a queue in a charging station. And so we can then run different threads representing each charging station concurrently. And so that's like the summary of what we did. Then, so also car obviously is an entity as well. And so what we have in this main method, which is start charging station simulation, is we have the users as an entity. We are simulating for 5 users. And so we have 5 cars as well. So this is like a name and car type for each user. And so we have a class called charging simulation where we we run the method to simulate the charging station and to start the simulation thread, basically. And so in this loop, basically what we are doing in this loop is to create instances for 5 cars, simulating an arrival of 5 cars. So for each of the car, we are generating a random wait time. That is the maximum time it takes for a car to be fully charged. So each of the random wait time we assign to the car. So this is like the delay. Then we assign the car. Then we add the car to a particular charging station or a queue in a particular charging station. So which is what we did here. So the car, the station index, and the user, we had to this simulate charging station method. So we'll be going into this simulate charging station method. You can see what we are doing here is basically creating 2 instances of a charging station. So we have 2 charging stations with a station A and station B, and with a maximum capacity of 3, a maximum capacity of 2. So this can only take 3 and 2 cars at the most. Then we created, so this simulate charging station method basically adds the car to a particular queue in a particular charging station. So that is what this index is used to determine, okay, which charging station is this car meant for? Is it charging station A or charging station B? And so that's what we did here. So simulate car arrival basically is a method in the charging station, class that adds to a queue. So charging station queue dot add car, user queue dot add user. So to have a record of the car and the user in each charging station. And so if we go back here, and so after successfully adding every car to a charging station, to a queue in a charging station, we can then run the simulation thread. So run simulation thread is called after that activity. And so run simulation thread is basically to start start the instances that we've created, of the charging station we've created. So this get availability to check if the instance is available. Is also a method in the instance. We'll be going into the instance very soon to start charging car. And so start charging car is a method to start the thread for each of them. So start charging car basically is it contains the logic to start the thread that handles the logic to get car from the queue, charges for a specific amount of time. If the charges for a specific amount of time, if the time has exceeded the maximum wait time for each car, the car leaves the queue, another car comes into the queue. If the time the car is spending charging is equal to the max wait time of the charging station, it gets kicked out of the charging station, basically. And once all of it is done, and the queue is empty, we can say, oh, this is done charging all cars in the station. So, but to run this for a test, we can run this start charging car with logs. This basically contains some log data that we can add to our log files. And so let's do that instead. So let's go back here. So start charging car with log should also log our file, our information as the car is charging. So let's build. And so as we can see, the first thing is car one is charging in station A, car two in station A, car three in station A, car four station B, car five station A. All these are assigned randomly from our main method. And so if we check the log files to see how it works. So in the user log, for example, these are the user created. The Jane is meant to charge for 3 seconds. Station A, maximum charging time is 5. And same with every other user. Then our charging station log, charging simulation shows the car and the station in which they are being charged. So car 1A, car 2A, car 4B, car 5 in A. Then charging station log, simulation, this shows our car and the maximum wait time for each car. So car 1, maximum wait time for car 1, it takes like 3 seconds to be fully charged, 8 seconds to be fully charged, 3 seconds, 8 seconds. All these are random times picked. So the charging station itself, so when the thread starts, we log it to say, okay, thread starts for station B, for station A. So because it is like you have dozen concurrency, they start at the same time, but different instances, different monitoring process, but they just run in parallel. And so station A is using energy source solar, station B is using energy source wind to charge the car. This is also picking at random energy sources that we've created. We have energy source as an entity file here, an enum basically. And so car 1 we charge for 3 seconds, car 4 we charge for 8 seconds. So car 4 we charge for 8 seconds. But the maximum wait time for a charge station, don't forget, is 5. So after 5 seconds, car 4 should be kicked out of the charging station. So as you can see here, car 4 is in queue charging for 5 seconds. So car 4 has charged for 5 seconds and left the queue. 3 seconds left to full charge. So it's left. So car 4 is done charging after 5 seconds. Car 1 in his own station, in station A, is charging for 3 seconds. So car 1A, car 3A, car 1 is done charging at 3 seconds. So that works as well. Car 4 in his own station B is done. So at when, because car 4 is the only car in station B, so once the car is done and there's no other car left in the queue, it's sending a message to say, oh, station B is done charging all cars in the station. Now it is available for new cars to be added to it. But station A continues charging, which is car 2 is in queue charging for 3 seconds. So this goes on until this again, 3 seconds left to full charge. So it's done charging, it leaves. Then the next car again, car 3 is done. So car 2 is done. Once car 2 is done, car 3 comes in immediately after. So car 3 charges as well. Once it's done, it leaves. Car 5 charge as well. This is just passing through basically 0 seconds. It leaves. Then once everything is done, station A is done charging all kind of station. Then our simulation basically works. So we can do this for as many charging stations as possible, for as many cars as possible. Yeah. Thank you.